This is the fifth video in the user-specified statistics module, and in this module we're going to revisit state statistics, and in this module we're going to track a statistic that Simio doesn't track for us automatically. And so if you recall from the previous video, we developed the state statistic for tracking the number of entities in the system. So this mirrors a statistic that Simio automatically calculates for us, but we wanted to see the basic process. And the basic process was we defined a model state called NIS, and then we tabulated the values, or we updated the values where appropriate. So for number and system, it's we increment the value when an entity enters and we decrement it when it leaves, and then we tell Simio to track the statistic, to track that value over time using a state statistic. So here's the model that we're doing. We're doing the circuit board placement model, model 5.2 from the textbook, and the state statistic that we're interested in for the current video is, instead of knowing the total number of boards in the system, what I want to know is how many boards that have failed inspection at least once, or that have been reworked, are in the system. So it's similar to the number of boards in the system, and we're going to get a profile or a time function that looks very similar to this, but of course it's going to be different because instead of the total number, we're going to be actually a smaller number, because you can't have more failed boards than actual boards, but a different number. And so that's what the focus of this video is using this three-step methodology for tracking the number of failed boards in the system. So let's do this. Our first step here is to define the model state. So we'll go back to our model. Oops, I left it running, so let's stop it. Make sure I have model highlighted over here in navigation. Go to definitions, states, and there's our NIS state that we did in the previous video. Let's add another integer state called num fails. And so this will represent the the number of failed boards in the system at any point in simulated time. And so of course that's an integer also. So let's go back and let's go ahead and add the status label so that we can track this value also. And so I just use copy and paste. I just copied the previous one, pasted it, and now we want to track something different. Num fails. So I'm going to run my model, just sort of watch, and of course we haven't set num fails to change ever. All we've done is define it. So I'm going to run my model, watch the values, and just again make sure that nothing changes to do some verification as we go. Okay, so we have that done. This second step in our process says I need to tabulate the values as the model runs. And so in other words, this is the heart of the logic. In my model, I need to decide how to increment the value of num fails when there's a new failed board in the system, and decrement that value when a failed board leaves the system. So our goal is to track boards that have failed. And so in other words, we have boards that follow this branch or this connector from the inspection process and go through rework. So our first approach, or our first idea, might be to just use a state assignment as boards enter rework. So for example, I could go in and say, okay, on entering, right, because we know at this point that a board has failed, I'm simply going to increment the value of num fails. So I'll just go num fails. If I could get my mouse right, num fails equals num fails plus 1. So when a board enters the rework station, before it started the rework process, I will just increment that value. So as I run, again, I'm going to watch that value, and every time a board goes through here, we should see that value increase, which it appears to be doing. There are two problems with this approach. One problem and one thing that we just haven't addressed. We haven't addressed decrementing. So in other words, this value will continue to increase because, of course, we want to increment the value when a board enters rework. Then we've got to decrement that value when it leaves. But let's put that aside for a second. Another problem with our current approach is that if boards fail multiple times, they get double counted. So if a board comes through inspection, goes through rework, this state assignment will increment the value of num fails, and then let's say the same board comes through inspection again and fails again. Well, that's the same board, so there's still only one failed board in the system, but it gets double counted. So what we need to do instead of this state assignment is we need to check and see if this is a newly failed board. So I'm going to delete that and go back and say, to do this, to do this check, I need a little bit more logic. So I'm going to define an add-on process when a board enters rework. So the key here is how do I know whether a board has been counted multiple times? In other words, how do I know if a board has been reworked multiple times? In which case I wouldn't want to count it, right? So I'm going to start out with a decide module, and I'm going to say if the board has already been counted, I'm just going to ignore it. Otherwise, I'm going to go to the false branch, and this is where I will do the incrementing. So I'm going to say num fails equals num fails plus 1. And I'm going to make this decide. I'm going to just go rename it has failed. Has failed before. So that I can, when I come back and look at this logic, I can tell what's the decision I'm trying to make here. And of course, if the board has failed before, I don't want to increment our num fails counter because this board has already been counted. Otherwise, I do. And so the question becomes, what is this decision? How do I make this decision? If we go back to our model and remember from the previous video where we were counting the number of times a board goes through placement, we had previously defined a model entity, right? An entity state, let me back it. We'd previously defined an entity state called num place. And we incremented that value every time a board went through placement. So we have a before exiting add-on process here that increments that value. So every time a board goes through placement, we now know how many times, or every time a board comes out, we increment that value. So at any point, we know how many times any given board has been placed. And so in order for a board to come through rework for a second time, that num place entity state has to be greater than 1, because if a pristine board comes through placement the first time, then the num place value will be 1. It fails inspection and it comes through rework. That value of num place is 1, and so that tells us that this is a newly failed board. If that same board goes through placement a second time, then num place will be 2. And so when it gets to the rework, we will know that we've already counted it. So the decision that we need is a condition, and that condition that we need is model entity num place greater than 1. So if it's any value other than 1, then we just ignore it. Otherwise, it's 1, it's a newly failed board, so we go ahead and assign the value. And so when we run our model now, we should still see every time a board placed, it fails. If you watch closely and long enough, and you see a board that fails multiple times, you could slow the animation down and actually see that when a board with a value greater than 1 comes into rework, the increment is not done. You should definitely do that, but I'm not going to do that in the video. And so it's just sort of a general modeling practice. This is what you want to do, is you want to, when you implement new logic, you want to make sure that that logic is correct. Okay, so the second part is, of course, to do the reverse of that when a board leaves. And so for our good and bad syncs, remember that we have an add-on process called record TIS that gets called both times. And so we're just going to piggyback on that, as we've already done, and we're going to essentially do the opposite of this process. So I'm just going to copy this value and say has failed. And so if the has failed before is greater than 1, right? Or I'm sorry, the num place is greater than 1, that tells me that this board has failed and has been counted. So I'm going to copy this value, paste it here, this time on the true branch, and I'm going to decrement the value. And so now, when a failed board leaves, right, we detect that it has failed because it's been placed more than 1 time. If that's the case, then we need to decrement the num fails. If we go back and run our model, now we should see that the value should go from 1 to 0 to 1 to 0 to 2 and so on, so that when a board fails, we count it. When a failed board leaves, we decrement that value. So back to our process. We've just completed step 2. As step 1, we define the value, the model state. In step 2, we incremented and decremented the value appropriately. Note that if you watch the previous video where we were replicating the number in system, that was significantly easier. There was less logic involved. In this case, we had to discern between boards that had failed multiple times. There was a little bit more logic involved, but it turned out to be the exact same process that we were incrementing and decrementing that value. The final step that we'll do is tell Simio to track that number. So we go back and we do that with a definition element. We need another state statistic, and I'm going to call this one fails in system, for the number of failures in system, and then of course I just give it this value of num fails. And I can then go and run my model, and I should now see a new user specified statistic. Go to my results, and there's my fails in system at 2.0879. I can also go back to my experiment, since now we have some new meaningful information, and add a response that has num fails, for example, and then we would get the state statistic, fails in system. Oops. Okay, try this again. My caps lock fails in system. Can't get that to get my period. Huh. Average. All right, finally, after all that typing on my keyboard, and when I run my model, we see that average number of failures in the system. Of course, I could also do the maximum number. If I want to have the maximum number of fails, instead of having that dot average, I would just have the dot maximum. So if I go and grab the statistic name, let's put that in, response 6, and just backspace through here and do maximum, for example, and this will tell you the maximum number of failures that we see in the system over any given run. So let's just name that max fails. And now when we run, reset and run, we can compare that average and maximum with the number in system. And as I said before, when we were building the model, when we had our erroneous way to tabulate the number in system, we would have potentially seen the average number of fails greater than the number in system, and that would have been our key. And again, that's something you should definitely go back and have a look at. So again, to summarize what we did, the same 3-step process that we did in the previous video. We defined a model state to track the value. We then updated the value according to the logic based on what it is we're tracking. And then we told Simio to track the number in system. And then finally, not listed here in our steps, but we created an experimental response to report that value.